Hello grade 12 students. This is an introductory chapter that covers some of the essentials in mathematics and physics that are needed for grade 12. At the end of this chapter, which is divided into different topics, we're gonna be able to relate the mathematics needed for grade 12. We're gonna study how to use the calculator, a non-programmable one. Then in the physics section, we're gonna go towards the previous physics requirements and how to choose convenient equations and relations to answer some questions. The outline of this chapter is divided into two sections. A goes for mathematics, in which we cover scientific notation, variables, equations, vectors, trigonometry and right triangles, derivatives and primitives as well. On the other hand, in section B, where we go towards the physics requirements, we cover units, motion, energy, electricity, and magnetism. Let's start now with the first section in mathematics, which is scientific notation and significant figures. Scientific notation is simply when a number is written in the form of a times 10 to power b, where a is any number between 1 and 10, and b belongs to z, it's a natural number. On the other hand, significant figures is the number of digits used to express a number up to a certain precision. For example, writing a number as 3.1 is different than 3.14. You all agree that 3.14 is more accurate than 3.1. So in significant digits or figures, we simply specify the amount of digits needed in order to express a number to a certain precision level. In general, zeros at the beginning of a number and those at the end of the same number are not counted as significant figures. The number of digits in scientific notation should be the same as that in significant digits of the number itself. Writing a number in scientific notation should always respect rounding rules that we have studied so far. Some examples about both scientific notation and significant figures. The number 23.78 has 4 significant figures, but it's not in scientific notation simply because the number 23 isn't between 1 and 10. Take the same number and write it as 2.378 times 10 to power 1. It still has 4 significant digits, 2, 3, 7, and 8, and it is now written in scientific notation thanks to the multiplication by 10 to power 1. 0.025 has 2 significant figures. Notice that the zeros at the beginning, before the decimal point, and after the decimal point were not counted. The number 2500 also has 2 significant figures because the 2 zeros at the end aren't to be counted as mentioned above. The number 0.06500 has 4 significant figures. Why is that? Because 65 and the 2 zeros that follow at the end after the decimal point are considered some level of accuracy and precision. You know, by adding 2 zeros at the end, you're informing the reader that there are no other digits that you have rounded when you have written 6 and 5. That's the idea of significant figures. Some notes regarding scientific notation and significant figures are collected in this table. For example, let's take the first line in which we have 203 million as a number, 203 and 6 zeros following. The significant figures are 3, 2, 0, and 3. These ones. Now the zeros at the end, these 6 zeros, aren't to be considered as mentioned. Writing the same number in scientific notation is 2.03 times 10 to power 8. Notice also we have here 3 significant figures. Let's erase these. Now, on the other hand, 0.0722 has 3 significant figures as well because these zeros aren't to be considered. Writing the number in standard form is with 3 significant figures 0.0722, and in scientific notation, as you should have guessed, it's 7.22 10 to the negative 2. 0.0045 has 2 significant figures, which are the 4 and 5 at the end. Zeros at the beginning aren't to be considered, Writing the number using 3 significant figures in standard form is just to add a 0 at the end. This 0 at the right side doesn't account for anything as we know in numbers, but it adds one level of precision. So if you write the number as scientific notation, you get 4.50, indicating that up to the second decimal digit, there are no roundings that were done. The number is 4.50 times 10 to the negative 4. 1.9027 has 5 significant digits. Also, if you want to round this number and write it with 3 significant digits, we take the 190. 0 is followed by 2, so we round down to get 1.90, and that's it. Or 1.90 times 10 to the power 0 in case we want to add scientific notation. 74.9600 has 6 significant digits because these two zeros are important to show some level of precision. Now, if you want to write this number using 3 significant digits, you look at the first 3 digits, 7, 4, and 9. 9 is followed by 6, so we need to round it up. And since it is 9, when you round it up, it becomes a new level or a new value, or a place value. In fact, that's why we add 1 to the 4 in the ones, and the number becomes 75.0 to account for the third significant figure, or 7.50 times 10 to the power 10, times 10 to the power 1. Now, to apply what we have seen so far, try to solve this application, which is composed of 5 questions, where you are supposed to write numbers in scientific notation with 3 significant figures. As intended, these videos are to help you work out and prepare yourselves. Please try to discuss this application with your instructors, and in case you are working on your own, don't hesitate to ask any question in the comments section below.